Hey all, this is Scalability Part 2, and today I want to continue to discuss the topic of scalability, and doing this by asking the right questions. So the first question we are going to ask is whether it is possible to bake in scalability into a startup. Now, even a better question would be that if you are already a startup, whether you want to bake scalability in, because if you will do that, then obviously this would have implications on how fast you can move on with your software development. So the answer to that, I think, at least in my mind, is very simple. And it is that first you should be aware of what scalability means. And this is what we are going to discuss in these episodes. And once you are aware of it, then you should not block. I mean, you should design your software. You don't have to implement scalability from zero, from for a little fast growing if you don't have really too many customers. I mean, if you have two customers, 10 customers, 100, you still even many more, right? You still don't need the scalability in your tool set. However, what you need to know is that what is better doing is that you what you bake in is not the solution, is that when it comes the time that you need to change your architecture, that you won't need to recreate everything from scratch. So there is this other possibility, maybe, that you know that when the time will come, you will be able to recreate everything. So in this case, this is okay, but you don't really know that. And if you don't really know that, then the thing is that with very little effort, you can avoid doing this revolution and this recreation or rewrite of the whole code base. And how can you do that? You can do it with simple steps. For example, if you have a database, you can always abuse the database or utilize it to the end. You can use every little non-standard SQL if it's relational database, every little non-standard query into this database and just use it all over the code base. And then when times come, you have and you understand you want to change the database mainly because it costs too much money and we want to move to an open source solution. Then you find out that you need to rewrite many of your queries and maybe it impacts all of your software. But if you wrote your software in a way that when you access the database, you less care which database you access. You less care whether it's even a NoSQL or relational database. You just do get into the database, the get by key and set by key, and maybe you do some searches. And when you have some specific queries, then you move them to the side to specific files, when later you can take those specific files, even you can call it by specific names, or so that later on when you move on to a different kind of database or when you change your architecture and you cannot do these complex searches on your database, and you need to change somehow the way you do searches. Maybe you now have sharding. We'll talk about this concept in the future. So so that in the future it will be much easier to access the database. So if you're using MySQL, then first I will recommend you, for example, right, to use another layer of abstraction. Now, when we say another layer of abstraction, you might think, oh, this is going to take me too much time to create this layer, but no, it just means another class or whatever, that whenever you call the database, you first call it and it chooses the implementation and instantiates it for you. Or if you have a different way. Now, we are also not fond of over engineering, so you should be very careful not to over engineer your solution. So we are talking about very simple things. I didn't really mention a map that loads the type of the database from a configuration, and this configuration is injected and stuff like this. All I said is that when you call your first database, you go through another function which is a general one, and it calls your database. This is the right amount of engineering, and if you really feel you need more engineering, then you can move it to a configuration file. But right now, when you're early on or you're on your startup, then you have a single database, so don't over engineer it. Um, so there is this balance that you always need to take care of over engineering that will cause you also to slow down, and under engineering that will cause you very bad implications even in the future if you get too much specific in your solution. And this question is also a very major one when we discuss the whole topic of scalability. Is how much engineering should you put into your solution, or how much over engineering should you put into your solution, so that in future when you need to do these refactors, when you need to do these changes, when you need to grow high, then it will, from one hand, be easy, and from the other hand, be easy for your current software developers to develop your code and be happy with it and not mess all day with over-engineered code. So the answer to that is a little of bit of art. I mean, there is not no specific solution, but the main guideline is first that you need to engineer your code first so that it will be clear and clean, and those are other aspects, but they are related because many times non-clean code means over-engineered code. So it should be first clean, and by clean we don't mean too many abstractions. It means in general that you should always try to read your code and understand from the user perspective whether it is clean and clear for the reader of the code, and you should apply different use cases, such as ask yourself, okay, what if I need to change the database? Okay, will I need to refactor the whole thing? And again, if you understand that you need to refactor the whole thing, this is not really a good point. But if you understand that you have a set of queries or a set of procedures that reside on the side or on some specific place that only them you need to take and change, then this is a good point. Now, if you rely on the architecture of your database, let's say for replication or some kind of sharding, then then from one hand this is okay, but you might maybe also want to check if there is if the underlying architecture can be applied to other databases. For example, if you use a specific feature of a specific database that knows to automatically shard your data, then this might be okay, but this will work only if other database will know to do that. So what you might want to do is to have some control on how you split your data among database. That is, if you have too much data, right? If you have too much data, then if you have some control, and so if you on because this procedure can be simple, yeah, right? In many times it can be presented as a very complex procedure, but you can treat it as a simple one, so that when you move to another database, you can apply the same procedure. So the main thing I wanted to stress in this second episode about scalability is that you should try to make your code clear. You should try to be able to change your code in the future without devastating and refactoring the whole application. And you should try to put a minimal effort into it. It doesn't mean you need to put too much effort in it. And it's possible. These things are possible. Next time you're doing something, think if it is possible to make it just a little bit generic, not too much generic, just a little bit generic with a little bit of abstraction, a little bit that will not make it too much complex, so that you can change the things in future and scale them in future. And with that, we end this episode, and I hope you enjoyed it. If you have any feedback, please let me know so that I know how to improve it. And I will see you in the next one. And again, I really want to stress out, please give me feedback about this episode so we know how to improve it for the next episode. Thank you, and I hope you enjoyed it.